Today maths class we'll be looking at modulus arithmetics, which is very common and sensitive in exam. Now, what is the concept of modulus arithmetics? Let's take a look at this clock system here. Now, if you look at this clock system, you see that the hour hand is at what? At 12. Now, mind you, we know very well that the clock system is viewed in two parts. You have in terms of 24 hours and in terms of what? 12 hours. Now, the clock hand has a fixed modulus of what? Of 12. So each of the rotation is fixed as what? 12. So this 12 is the fixed point. Is the fixed point of the clock. Now, when the time the clock moves and it gets to 12, which is the fixed point, it takes the movement again. Now, let's take a look at typical example of it. Now, this clock points at 3 o'clock. Now, it is 3 o'clock. The clock is 3 o'clock when it has the modulus fixed as 12. Now, if I should view it in terms of 24 hours, the clock is going to be 12, 13, 14, 15. It's going to be what? 15 hours in terms of what? 24. Now, let's look at another one again. Let's look at this structure. This is days, this is week. Now, this week, we have the week fixed at what? As X. Now, if I take each of the rotation of it, and I want to get forward for week 2, I'm going to start with Y, Z, the one that is fixed, X. If I want to take week 3, I'm going to start Z, X, Y. Now, this one is applicable when we are looking at market structures. Now, these are just common practical application of modulus arithmetics. We can also see them in terms of birthday anniversaries, wedding anniversaries, and a more practical example is the female menstrual cycle, which also follows the concept of modulus arithmetics. Cool. Now, let's look at the rules that guide modulus arithmetics. Now, rule 1, if the integer is less than the given modulus, it is written down directly. Now, that's the rule that guides rule 1. Now, rule 2, if the integer is more than the given modulus, the long division pattern is used and the remainder is taken as your answer. Now, we're going to look at how we're going to apply this in solving modulus arithmetics. Now, let's look at this typical example. We're asked to look at this modulus under addition of it. Simplify. 3 plus 2 mod 7. So what we'll do here, this is my solution. Now, I'm going to perform the operation normally. I'm going to add them normally. 3 plus 2 is 5 mod 7. Now, let's look at our rule. Our rule states that if the integer is less than the given modulus, it is written down directly. So, in this case, 3 plus 2 mod 7 is 5 mod 7. That's for this one. Now, let's look at example 2. We're asked to simplify 5 plus 7 mod 12. 5 plus 7 mod 14. 5 plus 7 mod 14. I'm going to add this one normally. That is what? 5 plus 7 is what? It's 12. Now, mod 14. It is written down directly because 12 is not up to what? 14. Now, in the other one, we're asked to simplify 23 plus 5 mod 14. Now, let's look at it. 23 plus 5 will give us 28. 28 mod 14. Now, if you observe, now let's look at these examples. 8 plus 3 mod 9. How do we simplify this? We add normally. 8 plus 3 is 11 mod 9. Now go back to 2. The integer is more than the given modulus. So what do? We break it down. Now, how many 9 can I see in 12? I can see 1. That is 9 times 1. Remainder what? Remainder 2. You understand? So I'll take the remainder as my answer. Therefore, my answer is 2 mod 9. If you don't want to solve using this pattern, you can use the long division pattern as given in root 2. So this place becomes the given modulus, and this place becomes the operation we got, the integer we got. 9 in 11 is what? 1, remainder 2. So therefore, 8 plus 3 mod 9 is giving us 2 mod 9 as my final answer. Now, let's look at construction of modulus table under addition. Now, there are little rules that guides this construction. That rule we call it integers congruency. Integers congruency. Now, what does the rule state? Now, the rule tells us that each integer has n minus 1 degree. Each integers has n minus 1 degree. What does it mean? If I'm giving modulus 5, for instance, and I want to get the integer, what do I use? I use n minus 1. So my given modulus is 5. 5 minus 1 gives me 4. That means the integers that will be under the table is going to be what? 4. That is why I have it as 0, 1, 2, 3, 4. And this side, 0, 1, 2, 3, 4. So how do I do it? I'm going to add it normally, having in mind the two rules we stated earlier on. Now let's go. 0 plus 0 will give me what? 0. 0 plus 1 will give me what? 1. 0 plus 2 will give me what? 2. 0 plus 3 will give me what? 3. 0 plus 4 will give me what? 4. That is how you get the first part. Now let's come to this side. 1 plus 0 will give me what? 1. 1 plus 1 will give me what? 2. 1 plus 3 plus 2 will give me 3. 1 plus 3 will give me 4. 1 plus 4 will give me 5. Now, since we are working with mode 5, and based on our stated rule, the given integer is equivalent to the modulus. So what do we use? We use the long division pattern to get the leftover. So what do? I'll draw my line. I'll put my what? My integers. I got 5. I'm working with this. This is the given modulus I'm working with. This is the operation I got when I added 1 plus what? 4. So 5 in 5 will give me what? 1, remainder 0. Based on our rule, we are asked to take 0 as our outcome. So here is going to be 0. Here is going to be 0. Now, let's come back to this place. 2 plus 0 will give me 2. 2 plus 1 will give me 3. 2 plus 2 will give me 4. 2 plus 3 will give me 5. So if I do the same thing, I'm going to have 0. 2 plus 4 will give me 6. So if I put 6 here, and I will apply the rule, 5 in 6 is 1, remainder 1. So the remainder is taken as my answer. Here becomes 1. Now let's come to this place. 3 plus 0 will give me 3. 3 plus 1 will give me 4. 3 plus 2 will give me 5. If I apply the same rule, this gives me 0, 1, 2. If I add here, this is 4, 0, 1, 2, 3. using the stated rule. So this is how you construct modulus arithmetics under addition.
Cool.
Now let's look at how we multiply modulus. Look at this typical exam question. We're asked to construct the modulus table for mode 4. Now what I'll do first is to get my integers. Now under mode 4, what will be the integers? Using n-1 degree of integers. So if I put my 4 here, 4 minus 1, that means the integers will be what? Will be 3. Now I'll draw my line. I'll draw this place. I'll put the operation I'm doing times. I'll put the modulus I'm working with, mode 4. Now, using my n-1, my integers are within close range of what? 3. That means 0, 1, 2, 3. Here will also be 0, 1, 2, 3. You multiply modulus using the same concept of what? Addition of modulus. Having in mind the rule that guides it. So look at it. 0 times 0 is 0. 0 times 1, 0. 0 times 2, 0. 0 times 3, 0. That's how you get the first part. Now under here, 1 times 0, 0. 1 times 1, 1. 1 times 2, 2. 1 times 3, 3. Under here, this is 0. This is 2. 2 times 2 is 4. Since we are working in modulus using the rule, now I'm going to draw my line. This is the modulus I'm working with. This is what I got. 4 in 4, 1 remainder 0. So I take the remainder as my answer. So here becomes 0. Now, the other one, 2 times 3 is what? Is 6. So I'll put here 6. 4 in 6, that's 1. Remainder 2. I'll take my remainder. Here becomes 2. Now, this one is 0. This one is 3. This one is 4. Since I'm working in mode 4, so what will it be? Here will be what? 0. 3 times 3 is 9. So I'll come here. This is 9. 4 in 9. That's 2. Remember what? 1. So here will be what? 1. So this is how. Now, let's look at how we multiply this modulus table. Since we are working with mode 4, we'll get our integers using n-1 degree. Now, 0 times 0, 0. 0 times 1, 0. 0 times 2, 0. All this gives us 0. Now, 1 times 0 gives us 0. 1 times 1 gives us 1. 1 times 2. Now, this is how we multiply modulus arithmetics. It has similar concept to the addition. Now, I've gotten my integers using n-1. So what do we have? 0 times 0. If you multiply it, this part gives you 0. Now if you come down here, 1 times 0 gives you 0. 1 times 1 gives you 1. 1 times 2 gives you 2. 1 times 3 gives you what? 3. Now if you come down here, 2 times 0 gives you 0. 2 times 1 gives you 2. 2 times 2 gives you 4. So how do I get the 0? Using my rule, 4 in 4, 1 remainder 0. I take my remainder as my answer. That is how I got the 0. 2 times 3 gives you 6. 4 in 6, that's 1 remainder 2. I take my remainder as my answer. Now let's come down to this place. 3 times 0, 0. 3 times 1, 3. 3 times 2, 6. 4 in 6, that's 1 remainder 2. 3 times 3 is 9. So 4 in 9, that's 2 remainder 1. So here becomes 1. So this is how we perform the multiplication of modulus table. Now let's look at this typical YA question. We are asked to use this table to simplify this question given. So what I will do first is to study the table critically. I will use each of them to get the answer out. Then finally takes my word operation. So let me take it one after the other. So let me take the first one, 4 times 3. Now let's look at the table. 4 against 3. If you study it carefully, 4, 3, that produce 4. You see it now? I take that again. 4 times 3. Trace it down, the outcome is 4. So 4 times 3 gives me 4. Now I'll take the other one. 2 times 1. Now I'll study the table again. 2 times 1 gives me 4. So what I'll do is to combine it now. So I have my new one, which is 4 times, under this I have it as 4. Then I'll study the table again. 4 times 4. That gives me what? 1. That means my answer. Now let's look at this typical exam question. We're asked to find the value of x under mode 5. So there are a few tricks that guides these things. The first thing I'll do is to form the sequence of this word mode 5. Now let's look at the sequence. We're given 3x for mode 5. Now let me form the sequence. The sequence of the given modulus. So what do I have? 5, 10, 15, 20. I can go on and on. Now what does the rule state that? The rule states that I am going to get the sequence such that if I add it to this, it can be divided by the unknown variable. So let's look at it. Now if I add it, 5 as my first sequence plus 4 divided by 3, what will be the outcome? 5 plus 4 is 9. 9 divided by 3 will give me what? 3. That means this sequence is possible. Now let's check other sequence. If I take 10 plus 4 divided by 3, what will it be? 10 plus 4 is 14. 14 divided by 3, that means this sequence is impossible. So if I go on and on, I'm going to get the one that is possible and the one that is impossible. Mind you, in finding an unknown variable under mode, you can have more than one answer, but you take the list. So what I will do, since I've gotten the list, which is what? Which is 5. So what would I do now? I'll bring the question properly. 3x is equals to 4 mode 5. That is 5 plus 4 divided by 3 is equals to x. 5 plus 4 is 9 divided by 3 is equals to x. 5, this is what? 3 is equals to x. Therefore, my x is equals to what? It's equals to 3.